Okay. We skipped a couple slides because they were question slides, but they'd already been answered, so the answers were there. We can look real quick just so you see them, but we didn't use clickers. We can't use clickers with this yet until the Wi-Fi. I can use this without being tethered to this cord, so we're working on that. That way I can then walk around, which will really help in lab, too, when you guys start next week, being able to move around and show pictures of other people's work. That'll be really nice. So this is just a question. All hormones released from the anterior pituitary require releasing hormones from the hypothalamus. True, false? Yeah, it is true. So I don't know if you remember, there's 9 hormones that are produced from the anterior pituitary. They are all considered tropins, or they're tropic hormones, and they all require a releasing hormone from the hypothalamus. Okay, that's really loud. Turn that down. So if GHRH, so gonadotropin, growth hormone releasing hormone, is released by the hypothalamus, what hormone will be released from the anterior pituitary? Yeah, growth hormone. Did you guys enjoy the cartoon? Okay, good. The cow working out using growth hormones. Okay. All right, so starting here with lecture, slide 33. So hormones, we've moved, now we're starting posterior pituitary. Okay, and note that there is a special note here that says handout and no. There are handouts up on Moodle. Why did I close Moodle? You guys can find it for the endocrine system, and it has a lot of great illustrations that kind of help visually walk you through what's happening. And I find that with this chapter, being able to kind of visually see some of the things helps with learning and memorizing and being able to recall information. So try to use those. Hopefully that's helpful for you. Okay, so we're starting right off with ADH, antidiuretic hormone. We have talked about it a little bit before, but now we're really going to talk about it. The other term for ADH, or antidiuretic hormone, is vasopressin. Not to be confused with somatostatin. Do you guys remember that? Oh, the other term for, let's just back up real quick. I want to make sure I'm saying this. Wait, there it was. Somatostatin, right here, is another word for growth hormone inhibiting hormone. Okay? So there's a couple that have different terms. So vasopressin is another term for antidiuretic hormone. All right, so how does this whole thing work? The picture on the side is small, I know, but in the handout it is much bigger. Okay? So with antidiuretic hormone, we have to have receptors. And so in this case, we have osmoreceptors, which are basically, they're neurons in the hypothalamus that are detecting changes in the concentration of solutes in the blood. Okay? How much stuff is dissolved in the blood. And so it's talking about, for example, the concentrations of electrolytes and water. So electrolytes, anything with a charge. So calcium is an electrolyte, chloride is, sodium is. What are other? Oh, potassium is an important one we've talked about before. So these are examples of electrolytes. So the concentrations of them. If the concentration of electrolytes, for example, is too high, then we need to dilute it. Okay? So we have osmoreceptors. So this little guy right here is supposed to represent an osmoreceptor up in the hypothalamus. The hypothalamus essentially monitors everything that goes on. Has a good blood supply that goes right past the hypothalamus, and so it's able to monitor the blood and all sorts of functions right there. So, if the concentration of electrolytes, is too high, so the concentration is really big, or if the concentration of water is too low. So if you don't have enough water, that's artificially going to increase the concentration of your solutes, right? Because the solutes, they're in the blood, and if you take some water out of the blood, the solutes are still there. So less water, essentially, it makes it seem like you have a higher concentration of solutes. So in either case, where you have an increased amount of electrolytes or a decreased amount of water, then you're going to have antidiuretic hormone being stimulated to be secreted. And that is coming from your hypothalamus, which will then send the signal down to your posterior pituitary. So the next step here, baroreceptors, which is not shown in this picture. We'll go over this picture in just a moment. But baroreceptors so if you look at the prefix baro, does that remind you of any other words? Sound familiar? Barrow? Barrel? That's true, but that's not the one I was thinking of. What about a barometer?
Sure.
What does a barometer do? Yes, it measures pressure. Okay, excellent. So we have pressure receptors, baroreceptors, in our heart. Look in the atria of the heart, there are baroreceptors. There are also baroreceptors in large veins, the carotid arteries, and the aortic arch. So I did mention on Wednesday that there is receptors in the heart, in the atria, that will detect the pressure. And so those receptors are baroreceptors. And so, yes, their job is to sense changes in the blood pressure within the heart or the aorta itself. Okay? So if the blood pressure goes down, the baroreceptors are going to know it. They're going to sense that. And that signal will then travel up to the hypothalamus and will also stimulate the secretion of antidiuretic hormone. Okay? So I just want to look at this picture real quick, and these illustrations are great because it walks you through the stimulus, what organs are involved, and what is the response to the stimulus. Okay? So I know this one is a small picture. So first of all, this is talking about antidiuretic hormone. So this picture is about antidiuretic hormone specifically. Two things trigger antidiuretic hormone to be released from your posterior pituitary. And so in this nice little purple box, it says it nice and summarized. So either you have an increase in blood osmolality, so an increase of concentration of solutes, of electrolytes, okay? Or there's a decrease in blood pressure, which essentially when you're saying there's a decrease in blood pressure, usually the cause is there is not enough water in your system, okay? Which is what it says over here. So one or both of these things will trigger the osmoreceptors. Here's that special osmoreceptor neuron in the hypothalamus. Remember, the hypothalamus is directly connected to the posterior pituitary. Okay, so then it sends a direct signal down to the posterior pituitary and tells it to release antidiuretic hormone. Antidiuretic hormone is released, and where does it act on? What organ does it primarily act on? The kidney. Okay, so the antidiuretic hormone works on the kidney. What are the effects of antidiuretic hormone on the kidney? Right down here in this lovely box. You've got to know this. So it will reduce the volume of the urine. So essentially you are saving more water. You're trying to prevent losing excess water through your urine. Increases urine osmolality. And so what that means is you're increasing the concentration of solutes in your urine. So you're going to have more stuff dissolved in it. So for example, your specific gravity, if you did that, would it be higher or lower if you increase the solutes in your urine? Remember that in lab? It would increase your specific gravity because you have more stuff dissolved in your urine. Okay. Then it also can decrease blood osmolality. And so by decreasing blood osmolality, it can do that by excreting extra ions. Okay. And it can also increase blood volume. And so the way it helps increase blood volume is it's conserving water in the kidney. You're excreting concentrated urine instead of large volumes of dilute urine. So that water you've saved goes back into the bloodstream, and that increases your blood volume. Because most of what you find in your arteries and veins, it's water with a bunch of stuff dissolved in it. Okay. Hormones of the anterior pituitary. Wow, we kind of bounced around. Did I hit the wrong button? Oh, that's strange. Okay, so I feel like we've covered this, but we'll go through this really quick. So a back up for 1 second. Anterior pituitary. So as a reminder, true or false? Anterior pituitary hormones are all tropins. They're all tropic. Yep, they're all tropins. Do they require... Does the anterior pituitary control itself? No. Who's in control of the anterior pituitary? The hypothalamus. So the hypothalamus, if it wants the anterior pituitary to release a hormone, what does the hypothalamus do? It releases a releasing hormone. Remember that? Silliness. So the hypothalamus releases a releasing hormone that goes to the anterior pituitary, and then it will release that specific hormone. So requires releasing hormone from hypothalamus. I need to figure out how to write smaller. Thalamus. All right, hormones, growth hormone. Remember the other word for growth hormone is somatotropin. Okay? Thyroid stimulating hormone, the TSH. Adrenocorticotropic hormone. So one of the things about tropins, do you remember what a tropin means, or what is a tropin? It acts, the hormone's released, and it goes and acts on another endocrine gland or another tissue. Okay? So growth hormone has a bunch of different tissues it works on, one being specifically muscle. Thyroid stimulating hormone is going to affect the function of the thyroid gland. Adrenocorticotropic hormone is going to go to the adrenal gland, specifically the cortex of the adrenal gland. Okay? Beta endorphins, lipotropins, luteinizing hormone, and follicle stimulating hormone. This we have in both sexes. And the releasing hormone, do you remember the releasing hormone for these two? It's the same. It's going to be gonadotropin releasing hormone is released from the hypothalamus, and it will stimulate both luteinizing hormone and follicle stimulating hormone to be released from your anterior pituitary. And then lastly, prolactin. Where does prolactin, or what does prolactin affect? Yeah, the mammary glands. Good, you got that one. Okay. So let's talk about the growth hormone, or somatotropin being the other term for it. So as I mentioned briefly, there's several different tissues and things that growth hormone influences. So one causes you to uptake more amino acids. Okay, so first, growth hormone is typically released when you're sleeping. And so that's why they say it's really important for kids to get a proper amount of sleep. Like I'm thinking about my son, 8 years old. It's important to get a lot of sleep because that's when the growth hormone is being released, and then they start eating like enough for like 3 men because they need all these nutrients like amino acids to build proteins. You build proteins that can go to muscle and for all sorts of other growth functions. Stimulates breakdown of fat. Fat is an energy storage molecule. So also will break down fat, so it's kind of increasing your metabolism a bit. Breaks down fat for more energy being available. And so also promotes bone and cartilage growth. So if you remember last semester we did bones, we looked at the epiphyseal plates. That's where bone is going to be growing in length. And sometimes when kids especially are growing, they can grow so fast you end up with growing pains. Have you ever experienced that? Yeah, those are real because you just grow so fast. In addition, growth hormone regulates levels of nutrients after a meal and periods where you're not eating. Okay, this is a very important hormone. It is, most of the time, it's released during childhood up until you're done growing, essentially. So ladies, we're done around 17 or 18 years of age. Gentlemen, you continue growing up to about the age of 25. But even as an adult, you still are releasing a little bit of growth hormone because it does have helpful effects. Okay, but we'll talk in a bit about some disorders that are associated with growth hormones. Oh, no, we're going to talk about it right now. Yeah. Okay, so effects of growth hormones. I forgot. So, 2 examples here of what can go wrong with growth hormone. So, on the left, we have Andre the Giant. You guys know who Andre the Giant is, right?
Oh, I do. I know a lot more than you.
The Princess Bride? He's the giant from The Princess Bride. Anyways, he used to be a wrestler, and he was really good at it because he's a giant. And he had the condition called gigantism, and this is when a person receives too much growth hormone as a child. So while they are growing, their anterior pituitary is releasing too much growth hormone. So they grow more than they should, and that's when you end up with people like Andre the Giant, or people who end up in the Guinness World Book of Records, for being like the tallest person for a certain time period because they essentially had too much growth hormone as a child. Now, on the other end of the scale, we have, I don't remember his name, the guy from Austin Powers, the little guy. Mini-Me, that's good. He, on the other hand, is a really good example of dwarfism. And dwarfism occurs when a child does not receive enough growth hormone as they are growing up. And so the body is fairly proportionate, and that's one of the characteristics of dwarfism. It's different than another form of little people. So the body is fairly proportional, and you just don't get enough growth hormone as a child. Now we can easily give children like that growth hormone therapy, but as we discussed in class, even one shot of growth hormones is expensive. My friend whose son gets growth hormone therapy, each shot he gets once a month is $1,000. And that's and they're on military insurance, which is like the best insurance ever. So growth hormone treatments are not cheap. Okay, another example, this is where as an adult, your anterior pituitary gland is producing too much growth hormone. So you're done growing, but then your anterior pituitary is starting to release too much growth hormone. That disorder is called acromegaly. And so I have 2 examples here. This lady here. This is shown, I don't know if it's over 3 decades, but this is her as a young woman before acromegaly started occurring with her. This is probably about 10 years later. And what differences do you see between her first picture and her second picture? Her nose is bigger. Her chin is more pronounced. Anything else?
Her hair is curly.
Well, yeah, she probably looks like she curled it. So nose, chin, her eyebrows, they look okay. So some of the features on her face are bigger. They're almost more masculinized in a way. Then maybe 10 or 20 years, I'm not sure, 10 to 20 years later, this last picture here, now what do you see the difference between picture number 2 and picture number 3? She almost looks like a man. So the nose is still big. What happened? What other facial features or changes do we see? The hands do get enlarged. Her chin, her face, it's enlarged and a little more mannish, you're right. Down here we have an example of a young man who also had acromegaly. And so this first picture, picture A, is prior to him showing symptoms for it. And this next picture is probably only about 10 years later, because he still is fairly young in this picture. What differences do you see in this young man? Guys, he probably just grew his hair out. Okay, let's not focus on the hair. Body features. Eyebrows. And his lips are bigger. His whole face is bigger. The hands, yes. It almost looks like he has more eyebrows, but it almost looks like he has like a more defined like brow line. You know what I mean? It's almost Neanderthalic, where it has kind of like that ridge of bone. It kind of looks like that right here. Okay, so yeah, it causes deformities. Now, notice how both of these pictures are from a long time ago? Yeah, this is something that we can catch and take care of now. So we don't see examples, at least in first world countries like America, where we have good health care. You may find people in other countries where health care is inaccessible or too expensive. You may find examples of that occurring in places like that. Okay, everybody answered this one. But just look at the options. Growth hormone in normal amounts would cause what? Would it cause uptake of amino acids? Yes. Would it break down fat? Why would it break down fat? The energy. And amino acids, why would it take up a bunch of amino acids? What are the amino acids, the building blocks of? Yeah, making proteins. So breaking down fats for energy, promotes bone and cartilage growth. Yeah, so the correct answer would be all of them. So we really didn't get too far. We had a quiz. That's all right. So we are going to start Monday on slide 39. And I'm hoping we'll be able to finish this Monday and get started on our next chapter Wednesday.